the special center we're going to learn about today is not going to be, you know, as kind of like useful, I'd say, as circumcenter and end-center. But it does have some interesting properties. Okay, so anyway, let's get into that. All right, so recall from yesterday, right, that the circumcenter, right, we just talked about this in the warm-up, it's found using the perpendicular bisectors, okay? It is, so if this is the circumcenter, point P, then the distance from P to A and P to B and P to C, okay, is all going to be equal. Whereas the incenter, right, this point right here, it is equidistant to the sides of the triangle. Okay, so the sides, however you draw your incenter, it will always be equidistant to the sides of the triangle. Remember the circumcenter could be outside of our triangle. We saw that happens with obtuse triangles, right? The circumcenter could be on the triangle. That happens with right triangles. And the circumcenter could be inside the triangle. That happens for acute triangles. For the incenter, just as a real quick question here, will those options be possible? Will all three of those options be possible? Can I have an incenter that's outside my triangle? Can I have an incenter that's on my triangle? Obviously, I can have one that's inside of it. So I see some no's. So anyone want to explain why we could not have an incenter that's like outside or on the triangle? What's that, Elizabeth? Right. Hey, how would you draw the circle then that fits inside the triangle if you have your center outside, right? Or if it's on the triangle even, how would you draw that? So exactly right. That's impossible. The incenter will always be in the triangle, but the circumcenter, it could be different places. Okay? All right. Next one. Let's talk about the last special point, and that special point is called the centroid. Okay, the centroid. So the centroid is not, it doesn't have the word center in it, although it does have the word central, you know, it has the word center kind of in it, but it's not in the same way as circumcenter and center. Okay, the centroid is not the center of some special circle. Okay, so it's centroid. So it's central in some sense, but not in the sense that it makes a circle. Okay, it is found using a special segment called the medians, or a median. So it's found using medians. Okay. Now you've heard the word median before. Can someone raise their hand and refresh our memory? What does median mean? Yeah, Michael?
It means you add up the amount of values and then divide it by how many there were. So say there are 5 values, you add those up and divide by 5 to get your median. Okay,
so that is the mean. Oh. That's the mean. Melissa? Right, after you put the numbers in order from least to greatest to least, whatever, it's the middle number of the data set. So, I mean, Mike and Michael, believe me, I get it. Like, that's like, I've heard that, like, so many times. And it's just, I guess, because everyone forgets about poor old median. Everyone just thinks right to the mean, and it's when you add them up all and divide by the number of numbers. Right, and all those things, the mean, the median, and the mode, those are measures of central tendency. They measure the center of your data. Well, obviously here, the median, we're not talking about the median as in, like, data analysis median. We're talking about a different kind of median here, okay? But there is that kind of middle idea that, you know, Michael and Melissa both kind of like hit upon there. So, what is a median? A median is, or let's see here, I should put the word A. A median is a segment, okay, that joins the vertex of a triangle, or I'll put a vertex, that's more generic. So it's a median is a segment that joins a vertex of a triangle with the midpoint of the opposite side. So there's that kind of middle idea, okay? It's a segment in our triangle, a segment that joins a vertex of a triangle with the midpoint of the opposite side. So let's get a triangle drawn up here. Okay, so let's draw a triangle. You can draw whatever kind of triangle you like. Okay, so there's my triangle. Boom. And I'll call this triangle, I don't know, GHI. All right, so Zishan, pick a vertex here for us. Which vertex do you want to pick? H. Great. Okay, so that means if I want to draw a median here, I have to join H to the midpoint of the opposite side. What is the side that's opposite point H there, Zishan? G. Not G or I. What's the name of the side that's opposite?
Segment GI.
GI, exactly right. Yes, exactly right. So H, okay, opposite angle, opposite the vertex H there is segment GI. So we need to find the midpoint of GI. How do we find the midpoint of GI? How can we do that? Yeah, Mary? You get to go. And here I thought you were going to help me answer the question. Okay. Go ahead.
Are you going to do perpendicular bisector?
Perpendicular bisector, exactly right. So that's what we're going to do here. So go ahead and do the perpendicular bisector construction. Good luck. Okay. So point on G, right? We're going to do a, I don't know if my paper, let's see if I can get this to work here. Yeah, like that. And then point on I. Okay. But then we got to be careful here because this is where it gets tempting to then just take our protractor and connect those two dots right there, right? But if I were to go ahead and draw this perpendicular bisector, okay, that would be wrong. What do we use the perpendicular bisectors to find? The circumcenter. So I am not going to draw the perpendicular bisector here. I just want to find the midpoint. So when I have my protractor all lined up, all I'm going to do is just mark the midpoint right there. That's it. Okay. We're just going to mark the midpoint. If you want to put little congruency marks there to show that those two sides are equal, that's fine. But we're just going to draw the midpoint. Okay. Now, I'm going to call that midpoint, I don't know, I'll call it midpoint M. And then Zishan, to finish drawing our median, what do I need to draw now? How can I finish it? Remember, a median is a segment that joins a vertex of a triangle with the midpoint of the opposite side. So what 2 points do I need to join together here? Yeah, H and M connect. Exactly right. And that then creates our median. Okay? That creates our median. So there is a median right there. So you could put like example HM. Okay, or EG probably would be a better way to do it there. But yeah, segment HM is a median. All right, so let's do another one. Because we got to find that centroid. So pick another side here. I'm going to do my side HG. Is that too loose, John? I can tighten that for you. Here, I can tighten it. I have a screwdriver. Mr. Croc, oh, I just stabbed myself. Mr. Croc, let me borrow his. So let's see if we can get this working for you. There you go. Okay, so we'll do HG again, football construction, right? Let's see. Okay, again, you do your football, you make like you're gonna, like you like put your protractor down just like you're gonna actually draw the perpendicular bisector, but you don't draw it. You just mark the midpoint of that opposite side there. And then connect the vertex to that midpoint. Thusly. Okay. And so there, X marks the spot, right? There is our centroid. Okay, there's the centroid. Okay, now, what is special about this point? In fact, let me go ahead and label that point C, maybe for the centroid. And I'll put this as N. Okay. The centroid, believe it or not, this is kind of interesting. Okay, the centroid is the center of balance It's the center of balance of triangle GHI. Okay? Do you guys know what I mean by the center of balance? Okay, so what that means is if we very accurately, if we did this very accurately, okay, and found that point very accurately, and if we kind of cut very carefully this triangle out, it should, in theory, balance on point C. So if you were to cut it out and balance it on like a pencil tip, you should put the triangle right on top of point C, and it should not slide off to either side. It should stay exactly balanced at point C. That's the center of balance. Okay. Now, I've actually tried this before, and I failed miserably. So I don't know if it was because of the construction or because there was wind blowing, air blowing in here that just kind of caught the paper or whatever. But that should be the center of balance. Okay, the center of gravity of the triangle there. It's a balance point. Okay, kind of interesting. Also, though, there's some numeric relationships in here as well. Okay, so for example, if I erase back some of these things here so that way it's not all crazy up in this place. Let's see. I'm just going to erase some of these little markings here so it doesn't look too crazy. Okay, so some relationships in here. Turns out, for example, if I look at segment HM here, which is the full median, okay, the length from H to C, this length here, HC is equal to 2/3 of HM. Okay, so this part HC is 2/3 of the full segment there, HM. Okay, so that's kind of an interesting relationship that shows up. And so if HC is 2/3 of the full segment, what does that mean CM has to be? Yeah, 1/3, exactly right. 1/3 of HM. Okay, yeah. Has to be 1/3. And the same is going to be true then for this other median, IN. Right? So for example, what fraction of the full median IN, what fraction of that full median will CI be? What fraction is CI of that full median there, IN? Any idea? Yeah, Hunter. Yeah, it's 2/3. Yeah, it's 2/3 as well. Now, Hunter, how are you able to tell that it was 2/3 and not the 1/3 part? What kind of clued you in there? Yeah, that's one way to think about it. Exactly right. CI looks bigger than NC does, so this is probably the 2/3 one, and that's going to be the 1/3 one. Exactly right. Okay. Also, I'll kind of clue you in here too. Let me see here. So that'd be CN equals 1/3 of IN. Also, it has to do with the fact that the distance from the vertex to the centroid is 2/3 of the full length there. So it's the part that's from the vertex to the centroid. Vertex to the centroid there is always the 2/3 part. And then the midpoint to the centroid is always then the 1/3 part. So midpoint to centroid is always the 1/3 part there. Okay? But yeah, so those are some relationships as well that kind of show up. Okay? So there are your three special centers you will be responsible for. The big two are circumcenter and incenter. Okay? Those ones you want to know for sure. The centroid one, it's important, but it's not so big of a deal. But definitely the circumcenter and the incenter. There's actually a fourth special center. It's called the orthocenter. It doesn't have any special properties. It just kind of happens. That's when you draw the altitudes of a triangle, which are like the lines that are perpendicular to a side that go through the opposite vertex, and that creates the orthocenter. But it's not that exciting because it doesn't really have any special properties. Okay. Some of you are probably thinking, none of these were very exciting, Mr. Whitmire. All right, fair enough. Not all of them are very exciting. But anyway, there's your special centers. Okay, so what I want us to do then real quick is go to the book, and we're going to look at some problems. So page 383, if you want to grab your books out real quick, page 383. We'll look at some problems here.
Page 383.
383. page 383. You're good, Tisha. Okay. All right, very good. So on that page, you can see here in the middle, it talks about what they call the Centroid Theorem. Okay, very official sounding, but we just talked about the relationship between the sides. So for example, here's the median AX. Okay, and it says that A to P, which is the centroid, is 2/3 of that full median. It's like duh. And then from B to P is 2/3 of the full median BY. And then from C to P is 2/3 of the full median length of CZ. Okay, so we're going to then kind of just get some practice here with that kind of concept. Down here, so looking at this triangle right here. Okay, we're told that AF, so from A to F, that full length there is 9. And then from C to E, that full median length is 7.2. So for example, if AF is a full length of 9, and I want to find AG, okay, well how is AG going to be related to AF? AG will equal what fraction of AF? 2/3, exactly right. So AG equals 2/3 AF, you can kind of see it there. I mean, they've already kind of done it out for us there too, but I'm going to write it here as well. And we know that AF is 9, so I can just replace AF with 9. I get AG equals 2/3 times 9. And what is 2/3 of 9? 6. Very good. Okay, for those of you who are like, wait a minute, fractions, Mr. Widmeyer, you can't make us do fractions in our head. Well, this one's actually not that bad to do in your head, right? 2/3 times 9 is the same thing as 2/3 times 9 over 1. And when we multiply fractions, how do we multiply fractions? Exactly. You multiply across the top, multiply across the bottom. It's probably the most intuitive, the most natural feeling, operation you do with fractions. Or you just 2 times 9, 18, over 3 times 1, 3, and what's 18 divided by 3? 6. So there it is. It gives you 6. Okay, that one's easy. Anyone could have done that one here. Okay, bless you. Okay, so there's 6. All right, there is a B question on the next page. It says to find GE. We're going to do that here, though, because I like to have the picture available to us. So I'm going to do that, bless you, I'm going to do that B, or GE, for section B, right here. My lovely desk is just going to be in the way. Okay. Okay. So GE is this fraction of CE. So what fraction of the big median here, CE, is GE going to be? Let's see here. What do you say? That's one we haven't heard from yet. So Keegan, what do you think there? GE, what fraction will that be of the big median right here? It's the 1/3, exactly right. So GE is going to be 1/3 of EC, or CE. And what is CE's length?
C.
Yeah, it's in the directions, kind of at the top there. Back to the original page there.
Oh, 7.2.
Yeah, 7.2, exactly right. Yeah, I know. They kind of put these information all over the place here. And so 1/3 of 7.2, that's a little bit trickier because it is, decimals and fractions and stuff, but it will be 2.4. Okay? So there's your answer there. Okay. Not too shabby, right? You can see over here, oh, this is fun, I don't know. There's me trying to explain how you kind of do the balance point thing. They tell you to cut out the triangle and punch a very small hole through point P, stick a pencil point through the hole, and then try to spin the triangle around the pencil point. How easily does it spin? I guess that's also supposed to show the center of balance. And if something's balanced well, then it will spin easily. Very interesting there. Thinking process. Okay. All right, one other thing we should be able to do with these medians and things is to... All right, whatever, I'll just sign up top. There you go. One other thing we should be able to do with these medians is kind of find them in the coordinate plane. And this actually makes it easier. Just like when we were doing the circumcenter in the coordinate plane, we can do these medians pretty easily in the coordinate plane as well. So in the directions here, it says to find the coordinates of the centroid of the triangle shown on the coordinate plane. Okay? So in order to do that, we have to draw in the medians to find the centroid, right? So, Tanner, how might we go about doing that? What do we need in order to draw the medians? We need to find the what? A midpoint. So pick a side. PR. Okay, can you eyeball the midpoint there of PR? Not really? Have some difficulty? Okay, can you at least tell me what the y-coordinate would be for the midpoint?
2,
Yeah, it's going to be 2, okay? And can you tell me maybe approximately what the x-coordinate would be?
4.5.
And that's exactly right. It's 4.5. So it's going to be 4.5, comma 2. It's right there. Okay, there's the point. Okay, right in the middle. Of course, if you guys get stuck and you're like, oh, I'm not sure how to, how to tell whether that's the midpoint or not, you can always use your compass and straight edge if you want. We'll just connect those 2 points. Okay, so there's our one median. All right. And then, Melissa, can you eyeball another midpoint, either for side RQ or for side PQ? For PQ, okay, yeah? 1.5, 4? Yeah, that looks good to me. Right there. Okay, and so then again, we'll just... And so then there is our centroid, right? So that the centroid has coordinates 3, 4. Okay. Don't forget, we also have the midpoint formula, right, on the coordinate plane. So we could find, for example, the midpoint of PR by using the midpoint formula. Let me just show you that real quick. So the midpoint formula, remember, is it's the x-coordinates added up, so it'd be 6 plus 3 over 2, and then the y-coordinates added up and divided by 2. Okay, so 6 plus 3 is 9. Divided by 2 gives us 4.5. Oops, I'm off the screen. There we go. Okay, all right, 6 plus 3 is 9. Over 2 gives us 4.5. So the x-coordinate is 4.5. And the y-coordinate is 4 plus 0, so 4 divided by 2 is 2. And so there's the midpoint, which is exactly what Tanner was able to tell there just by looking at it. Okay? So that's another option there, too. If you're unsure about what the midpoint might be, you can also calculate it using the midpoint formula. Okay? Alrighty. There's that. Any questions on that? I think that's it. Okay. So that's for that section, okay, and I'll give you guys your assignment here in just a sec, but I also want to skip ahead to the mid-segments. So if you would turn, please, to page 395. We'll look at this word mid-segments real quick. This is a short section, though. Okay. Short. And I'll get you guys started on your homework. Should be good. Okay, so mid-segments. What is a mid-segment? The mid-segment of a triangle is a line segment that connects the midpoints of 2 sides of the triangle. So if you look here in this little swing set, right, you've got a big triangle formed by the 2 arms of the swing set there and the ground. And then you have this kind of crossbar right here. So this bar right here would be like the mid-segment. Okay, so that's this segment right here is like a mid-segment. Okay. So there's the mid-segment. Okay. We could construct the mid-segment easily, right? If we did the perpendicular bisector of this side to find the midpoint, and we did the perpendicular bisector of this side to find the midpoint, and then connected the 2, we're connecting the 2 midpoints there, that would create a mid-segment. Okay. So, this mid-segment, why do we even bother talking about it? Well, let's see, does it say? Well, anyway, there's a relationship here between this mid-segment and the third side of the triangle. Okay? So, for example, there's a relationship between the length of this third side and the mid-segment. Anyone want to take a guess or can make a conjecture about what they think will be true between the length of this third side and the length of the mid-segment? Yeah, it's going to be half. Exactly right. The mid-segment will be half the length of the third side. Okay, so the mid-segment is half of the length of the, how do I want to talk about this? The third of the, I'm not sure how they say it. So mid-segment is half of the length of the other side of the triangle. And there's actually one other relationship too. Yeah.
It's halfway up.
It is halfway up, exactly right. I'm also talking about it's got one other relationship to this third side as well. If you were to extend the midsegment and make it a line, and if you were to extend the third side there and make it a line, would those two things ever intersect? No. So Lindsay, they would be what? Exactly right. The midsegment is half length of the other side of the triangle and parallel to it as well. Okay, so parallel and half of the length. Okay, so that's the key thing there. Key thing to remember. So that means, for example, this angle right here, this angle, how should that compare to this angle? They should be the same. Why? What special angle pair is that from our parallel side unit? Yeah? Corresponding, exactly right. These two angles are going to be congruent because they're corresponding. Likewise, we have another pair of angles right here that will also be congruent for the same reason. Okay? So those two angles will be corresponding. How about this, though? What about this angle and this angle? How will these two angles be related? They're another special angle pair. So again, this angle and this angle will have another special relationship. Yes, they're co-interior, Drew, exactly right. Which means they will what? Yeah, so these two angles are co-interior as well as these two angles are co-interior too. So very good. Okay. So let's see here. We'll look through this. All right, so we'll look through this example and then I'll just give you guys your assignment because I think we'll be able to get this just by looking at the example. Okay, so in Explain 1 here, it gives us quite a bit of information. So we can confirm our conjecture about midsegments using the formulas for the midpoint, slope, and distance. So in the directions here it says, show the given midsegment of the triangle is parallel to the third side of the triangle and is half as long as the third side. So looking at these two, looking at the midsegment here and that third side, how could we show that JK is parallel to GI using the coordinate plane here? How can we show that? Yeah, Michael?
Slope.
Yeah, use the slope, exactly right. So how can I find the slope of JK, or what is the slope of JK? 1/2, so let's see, you counted that, right? So we go up 1, 2, and right 1, 2, 3, 4. So yeah, 2/4, which simplifies to 1/2. So what should the slope of GI have to be then, Michael? 1/2 as well. So let's see. So if we count from G to I, we'll count up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. So slope of GI is 4/8, which then is also 1/2. So is JK parallel to GI? Yeah. Because the slopes are the same. Oh, sorry, I'm off the screen there. Okay. Now to show the lengths are half, okay, to show that JK is half length of GI here, we would have to use the distance formula. So here, I'll just kind of show that to us because I don't think I'm going to have quite enough space to show the distance formula calculations. But there's the distance formula, right? x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You take the square root of that sum, okay? So the length of JK, they found it to be square root of 20, which is equal to 2 times the square root of 5. GI, they found to be the square root of 80, which is then simplifies to 4 square roots of 5. And what do you notice here? Is 4 square roots of 5 twice as long as 2 square roots of 5? If you multiply this by 2, you do get 4 square roots of 5 there. So yeah, they are. GI is twice JK there. Okay, so it does work out that way. All right. Okay, so that was pretty quick. I want to just blow through that real quick because I think you guys can get that no big deal, no problem there. And we should be then okay. Yeah. Oh, and so there's finally the triangle midsegment theorem. No. Okay. So there it is right there. The segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is half the length of that side. So there it is for you right there. Okay? I didn't break that. All right. So, let me give you guys your assignment. So, back on page 390, I'm kind of get into this here.